Today the topic I already started yesterday, but let me just only link between the topic yesterday and the DB for yesterday and the topic today. Today is related to the power transmission throughout the shafts and gear. Do you know, ya shabab, what we did before? Yesterday we tried to calculate something which is the shear stresses due to the torsion, torque. Okay, which is can be calculated like that. Just I'm sorry, Shabab. Okay, I got a call. Right. So what we did yesterday we had a shear stresses, okay, that created due to what can I see the torque. Torque is nothing but it will be the torque, which is this multiplied by the rho divided by the G. Okay, so if somebody will ask you, okay, what will be the application in the power transmission, because actually the power will transmit through the torque, so you need to calculate the shear stresses of the shaft in order to design it and to make safely the power transmit through the gear without any collapse. Also we also due to the torsion is something which is related to the torque multiplied by the L divided by shear modulus divided by the boral moment of inertia. Also, you have to design your shaft to transmit the power, okay, through the gear and the what can I say, the shaft without any problem in the deformation or the angle of the twist. Okay. I hope it's clear now. طيب. So this is the just only the equation that I need from you to understand. How can we convert now the power into what can I see, a torque? There is a relationship between the power and the torque, and this can be founded from this equation. The power is nothing but it's equal to the torque multiplied by the shaft angular velocity, and this omega, okay, can be found or can be founded or converted into 2 pi f, in which f is the frequency of the rotation or the number of the cycle the shaft makes per second. So if you have the frequency and you have the power that need to be transmitted through the shaft, you see that we can find the torque. Once you can find the torque, you can find the stresses. Once you find the stresses, you can find or design your shaft in order to satisfy the requirement of the allowable stresses or the allowable deformation. So what I need from you to understand these equations, and also, ya shabab, I need from you to understand this is the unit power that can be used in the SI system, which is 1 watt is equal to 1 Newton meter per second. Okay, and also the 1 horsepower, okay, is equal to 550 pound-foot per second, and also the 1 horsepower, okay, this is in English unit, okay, which is the pound and feet, is can be converted into 746 watts, okay, and it will be just only 746 Newton per millimeter second, okay. The unit of the frequency, it can be measured in hertz, or it can be measured to revolution per unit time. So you just only convert it into the correct or the proper unit, so that there will not be different in the unit. Okay, so the torque can be calculated on the shaft from the power by divided by the 2 pi and multiply the frequency. If you have the torque, now you can find the shear stresses, you can find the angle of the twist, so that you can design your shaft to resist or to transmit this kind of the power. Okay. So this is the gear motor, as shown above, can develop 1/10 each power. This is one of the example when it is turns at 80 revolution per minutes. Okay, if the tau allowable is equal to 4 ksi, okay, determine the smallest diameter of the shaft to the nearest 1/8 inch that can be used. What they want from us here, they say they give you this power or motor, and it can develop 1/10 each power or horsepower. Okay, so that this is the power when it turns at 80 revolution per minute. This means this is the frequency. So what you have to do here, okay, we have just only to calculate the torque, okay, that will be produced by this kind of power. It can be calculated from here. The power is nothing but it's equal to 2 pi f multiplied by the t. Okay, so that, okay, the power can be calculated, the frequency, the power you have it, the frequency you have it, you can calculate the torque. Now we know that, okay, when we have a torsion or a torque applied to the certain shaft, the shear stresses can be calculated from this formula, if you remember, which is the T multiplied by the C divided by the G. Now, in order to calculate the maximum shear stresses, the C should be the radius of the shaft, and T will be calculated from here, and this G will be calculated from the property, which is not given. This is what they want us to find it, okay? And also the R can be just only represented as the unknown. So he gives us what will be the allowable shear stresses. If I will equate the allowable shear stresses and solving for the diameter, I think you can find it to satisfy the requirement of the tau allowable. Right? But you have to be careful when you will find it. You have to round it to up to 1/8 inches or the 1/4 or whatever. Yani round it to the whole number with a certain 1/8, I think it will be 1.25. If you want to round it to the second one, it will be 0.25. You just multiply by 2, okay? So this is what I mean by rounded to 1/8. So this is the power. We should convert it into pound per foot, okay, per second. By multiplied by 550, the horsepower should be converted into pound foot per second. By multiplied by 550. The frequency is nothing but it will be 80 revolution per minute, okay, which is can be like that, okay. You have to be careful because here will be second, here will be just only a minute, okay. So that we just only you use this one and that one in order to find what will be the torque. The torque nothing or the torsion is nothing but it will be the power divided by that, so you will get it in a pound per foot. Now, once we have a torque, you need to calculate the maximum shear stresses due to this torque applied to the shaft. How can we calculate it? From the equation, let me just do it here. If you assume that the shaft diameter will be D, so the shear stresses can be calculated due to the torque, either in a solid shaft or in the hollow shaft, by using this formula. This is the torque, I have it. The C should be the diameter or the radius, okay, which is D/2. This is, I don't know it. Divided by G, LG, if you remember, it will be pi over what? Over I don't remember. Can you tell me what is the G for the shaft? It is pi over 2 C to the power what? 4. Okay. So it will be like that. This is the tau. This is the T. This is the C, which is D over 2 divided by pi over 2 multiplied by D over 2 to the power 2 to the power 4. So now you have this equation. We need to find a D so that a tau or the shear stresses in the shaft will not exceed the tau allowable. A tau allowable here, it will be pound per square inch. You have to be careful. Therefore, a T should be converted into what? Pound per inch, not foot. So you have to multiply it by what? By 12. Okay? This is just only. And the diameter here, you can keep it as it is. Here it is like, for example, 4 KSI, which is the 4,000 pound per square inch. So you will just only equate it here and solving for the D. طيب? Once you will get a D, okay, once you will get a D, okay, you should round it. He said round it to the nearest 1 over 8. 1 over 8, ya shabab, it is nothing, but it will be just only 1 over 8. It will be 1.125. If you want to get the another round, you have to multiply it by 2, so that it will be 1 over 2, so it will be 0.25. So this number will be rounded to where? To 0.25. So I will use a diameter, not 0.2029, because it is difficult to apply it in practical. So you have to do it like 0.25. I hope it is clear. Is it clear, ya shabab? Is there any question?
Doctor.
Yes, please.
In which step we multiply by 1 over 8?
In which step we multiply by 1 over 8? You will not multiply by 1 over 8. What is the meaning of 1 over 8? ال 1 over 8 اللي هي rounded. يعني على سبيل المثال لو كنا عند ال SI unit بيقول لك rounded to 10 millimeter or to 5 millimeter. يعني if you will get a number like, for example, 0.12, okay, you will round it to 5 millimeter, so that you will round it 0.215. okay, يعني this is the number, the whole number that you rounded. هنا لأنه بالإنش يا شباب, okay, it can be rounded إلى 1 over 8, 1 over 4, multiply by 2, it will be 1 over what? 2, multiply by 2, it will be 1. يعني if you have a diameter that you will get it, like for example 0.95, for example, here you round it to 1, so that you will see now I will use 1 inch. Or if you will have, like for example, a diameter, you will get it 0.45, so that you will round it, okay, to 0.5. If you will get a diameter 0.2 something, you round it to 0.14, 1 over 4 اللي هي 0.25. This is اللي هي rounding number in the English unit. فهمت علي يا باشا? Is it clear? About the 1 over 8. ال 1 over 8 هي rounding number, not multiply. فهمت؟ معايا؟
Yes, yes.
يعني if you will keep it like that without rounding to 1.8 ولا 1.4, it's okay. فهمت علي؟ Is it clear?
Sir, I get it.
طيب, now يا شباب, we will come to another example which is related to the pump as shown above, operates using a motor that has a power of 85 watt. If the impeller or اللي هي البكرة, okay, at a B, okay, impeller, okay, at a B is turning at a 150 revolution per minute. Determine the maximum shear stresses developed in the 20 millimeter diameter transmission shaft at A. What they want here, ya shabab, they want from you to calculate the maximum shear stresses. If this kind of shaft will transfer a power that is equal to 85 watt, 85 watt, which is the Newton meter per second. طيب. And the frequency is nothing but it will be 150 revolution per minute. You have to convert a minute into second, so that you have to divide it by 60. So once you have the power and the frequency, you can find your just only torque from this equation, which is the power divided by the 2 pi, okay, divided by the frequency. Be careful about the unit. طيب. Once you have a torque, now we can calculate the maximum shear stresses in this shaft, which is a solid shaft. He gives us only the diameter. The maximum shear stresses is nothing but it will be the torque multiplied by the C, which is the diameter, the radius, which is 10 in this case, divided by G, which is just only pi over 2, multiplied by the radius to the power 4, which is 10 to the power 4. So you have a T, you have all of this, so you will calculate the maximum. Since you use LR or the maximum radius, okay, you will calculate the maximum shear stresses. We agree that when it will be the maximum shear stresses, when you will use the outer radius, either for the hollow or for the solid. So this is what I need from you to understand. So it is like that. This is the power. He just only put it in a Newton meter per second. The frequency should be converted into revolution per second instead of revolution per minute by divided by 60. This is the torque, Newton meter. This is the diameter. This is the C10. This is the G. And then after that, you will find the tau maximum. Okay. Now, if somebody will ask you, can you check if there is no failure for this shaft if you have this material or this shaft can resist up to 2 allowable, which is equal to 5 megapascal? What do you think, ya shabab? If the shaft can resist it up to 2 allowable, which is 5 megapascal, what do you think? Due to the applied torque or due to the applied this power, and this power will convert it to the torque, and this is the shear stresses due to this torque, what do you think?
It will not resist.
No, it will resist. لانه هنا الابلايد الباور كان ايش؟ create stress 3.4 لكن كماتيريال it can resist up to what? 5. Is it okay ولا not okay? If somebody will tell you, is it safe ولا not safe?
Yeah, it's safe.
Yes, it is safe. يعني مثلا it is okay to use this shaft to transfer or transmit this power without any problem. لكن if you increase this one to twice, what will happen to the torque? It will increase to twice, isn't it? And then this one will increase to twice, so it will be 6.8. 6.8, is it okay? No. So your shaft will subjected to the failure. You got my idea? Not failure, يعني it isn't safe. You can see it, okay? Because this is a tau allowable. طيب. Anyway. This is another example. He said that a steel tube, as shown above, having an outer diameter of D1 is equal to 2.5, is used to transmit a 35 horsepower when turning at a 2,700 revolution per minute. Determine the inner diameter D2 to the nearest, okay, 1/8. If the tau allowable is like that. This is exactly similar to the first problem, except here we have a shaft which is a hollow instead of the solid. So the first thing we have to convert the power into the pound foot per second by multiplied by 550 if I am right. Then after that we have to convert the frequency, which is 2,700 instead of revolution per minute to revolution per second. Then you can find T, which is the torque. After you find the torque, you can just only find the shear stresses in this tube. And in this tube, the shear stresses or the maximum shear stresses will happen when the T will be calculated from here. And the C here will be based on the outer diameter, which is just only the is equal to 2.5 over 2. طيب, divided by what? By the G. G in this case is nothing but it's equal to what? The pi over 2 multiplied by the outer diameter, okay, which the one that I want to find it, over 2 to the power 2 minus the inner diameter or radius, okay, it will be just only the 2.5, okay, over 2 to the power, this is to the power 4, ya shabab, by the way, to the power 4. So you can solve now for the outer diameter or the inner diameter. I think he give us the outer diameter, isn't it? So it will be just only here, I'm sorry. You see in the C, the outer. In here, this is the outer, it will be 2.5 over 2. Here it will be the inner diameter because he asked about the inner diameter. If you can find it from here, you can equate it to the allowable shear stresses, okay, which is here. And then after you multiply it by 10 to the power 3 to convert it instead of KSI to pound per square inch. So you can solve here and you will get what will be the inner diameter. Once you will get it, you can round it to what? 1 over 8 if it is less than 1.125. But if it is greater than 0.125, you can round it to 0.25 and so on. So this is what I need from you to understand. The power will be converted. This is just only the outer diameter. A C that you will calculate it in the torsion will be this one. This is the C2, okay, based on the inner diameter. This is the G like that. And this is the horse or the power should be converted into pound per foot per second. This is the frequency after we convert it into revolution per second by divided by 60. The T can be calculated from this formula. And don't forget, ya shabab, el pound per foot should be converted to pound per inch in order to use it in the equation. Now you just only apply to this formula and then you will get what will be the diameter. Here at diameter, ya shabab, it is more than 1, more than something like that. So that this one has to be rounded to 2.5, okay? Because actually, as I told you, okay, before, you just only rounded to 0.125 or 0.25 or like, for example, 0.5 or 1 or 1.5 or 1.25 or something like that, or 2 or 2.5 to something like that. So this one can be rounded ila 2.5, okay? This is what they mean by rounded to 1 over 8 inch, okay? So he didn't round it, okay? It will be 2.4, 2.5. Is there any question, ya shabab? Is there any question here? Is there any question here? Any question, ya shabab?
Clear.
Right. Now coming to another trick problem, and this trick problem I will highlight a certain trick. You have to keep it in your mind, okay? So that you have to if you come if you will get some problem like that, you have to keep it in your mind. Here a motor at a E, as shown above, develop a power of 300 watt. Yani the motor here, okay, develop a 300, okay, watt as a power, and it try to turn it. It's connected بولي at a 90 revolution per minute. يعني البولي هنا try to يعني rotated at a 90 revolution per minute. So we have the power here, we have the frequency, we can calculate the torsion here. See هنا يا شباب what will be the trick. Torsion here can be calculated easily from the power divided by the 2 pi multiplied by frequency. This is just only here. طيب, fantastic. So I can design what will be the shaft here, okay, if I know the tau allowable as the age what we did it before. Fantastic. So the shaft here, I can find the diameter easily. لكن he asked me here determine the required diameter of the steel shafts on the pulley at A and B. So we have to find, okay, what will be the diameter here and what will be the diameter here. The problem here, I don't know what will be the torsion. But keep it in your mind, okay? You have a formula that can be derived easily, okay? That you can link between the pulley, small pulley to the large pulley. And you can link between the torque applied to the shaft in the small pulley and the large pulley and the opposite. So the shaft or the torque in the small pulley divided by the radius of the small pulley is equal to the torque in the bigger pulley or the other pulley divided by the radius of the bigger-ish pulley. If you know the TA from here, and you know the radius of the pulley, which already give it to you here, which is 60, and you know the radius of what? Of the, what can I see, the big pulley, I can find easily what will be the torque that will be applied here. If you know the torque at B, I can calculate the shear stresses at the shaft at point B, which can be calculated from the T multiplied by the C divided by the G. C here will be the radius of the shaft here, and the G will be the G or the molar moment of inertia at the for the pole, the shaft at here. So once you have this one, okay, you just only calculated the TB, and then after I'm sorry, you can just calculate the tau and equate the tau with the tau allowable. You can find what will be the diameter of the shaft at a point B. طيب? So this is the idea. This is what? This is the idea of this problem. طيب? So from here, I can calculate what will be the torque in this shaft at the point A. It will be calculated from here, from this formula. You will calculate the torque from this formula as he gives us all the information here. And then after that, okay, I will just only go to the shear stresses for the shaft at the point A by calculated from this formula. Torque, you have it. Rho, you should substitute by the radius of the shaft, which is the diameter over 2, divided by the polar moment of inertia. You just only calculate it from here, and you will get the diameter of the shaft at the point A. Very simple, straightforward, but you have to be careful about the unit. Now, if you want to find what will be the shaft at, or the diameter of the shaft at the point A, B, so that, okay, the allowable shear stresses will not exceed also 85, you have to get first what will be the torque or the torsion that will be transferred through this shaft. As I told you, there is a relation between the torque at the pulley A and the torque at the pulley B. By this relation, torque at the pulley A by the radius of the pulley at A equal to the torque at the pulley B divided by the radius of the pulley B. So the radius of pulley is 60 at the point A. The radius of the pulley at point B is 150, which is giving like that. Therefore, I have the torque A from here, which is equal to this value. So from this value, you can get what will be the torque B, and based on this one, you can find what will be the diameter of the shaft at point B. Is there any question, ya shabab? Please. I think it is just only applied directly to a certain formula. If you understand how to apply it, I think everything will be fine for you. Okay? طيب. Any question, ya shabab? طيب. I think this is the last problem, if I am right. I don't know if this is the last problem. Yes, this is the last problem. What I need from you here, ya shabab, okay, just only, okay, he give you, this is a solid steel shaft, EC, from E to C, same shaft. but it is subjected to a different power through a gear. Like for example, a power here is equal to 1 kilowatt, and a power here is equal to 2 kilowatt, and here by this motor it is just only 3 kilowatt. The shaft is just only turn, okay, at a 50 revolution per second. He give you here the frequency. What they want from us to find, they want from us to find what will be the maximum shear stresses developed in the shaft within the region EBBC, isn't it? And the shaft is a free to in its support bearing D at E. I will explain to you what is the meaning of that. Here, ya shabab, you have to keep in your mind, okay, that this is like that. Okay, you have a shaft here. You can assume it whatever direction. If you assume it like this direction, okay, this will be the torque that will be produced at A from this power. This is also the another one, okay, which is at a TB. For sure, at a TC, it should be in which direction?
To the right.
In which direction?
To
the right. So that to make them to make them under equilibrium. You see, ya shabab, hina. Our target to find what will be the T. What will be the TB? What will be the TC? TC, we know what it's equal the sum of this. Who can tell me how can I find the TA and TB? Who can tell me? By using اللي هي الباور divided by 2 by the frequency, isn't it? الباور you have it 1 kilowatt, but be careful here, it will be 1 kilowatt. What you have to multiply it by 1000 in order to convert it to Newton meter per second. Frequency already he give it to you as a 50 revolution per second, so that you can use it. So I can find it. Same thing you will find here. So if you want to find the shear stresses within EB, how much torque here? Who can tell me? How much torque within this part is equal to what?
1.
It will be what? 1 اللي هو TA اللي هي 1 from الباور, لكن I want it as a TA from this equation, صح؟ طيب, once you have it, you just only calculate the shear stresses. What about here? Who can tell me what will be the torque here that will be that will be used to find what will be the shear stresses?
3.
It will be 3, exactly. 3 as a power, but we need to convert it to what? To a torque, exactly. So you just only find like that. This is the torque at a point C, which is based on this 3, okay? So if you will take this side, okay, it will be 3, it will be 9 point something. The torque at a point A, it will be 1/3, لأنه إذا كان هنا 3 وهذه 1, instead of recalculated from this formula, just divide it by 3, you will get what will be TC, صح? Because this is the same shaft, same revolution, so that frequency, so that you can get it easily. So the shear stresses at EB is nothing but it will be calculated from this torque multiplied by C, which is the radius, divided by G, which is calculated like that. You will get it like that. Now, which one is the maximum? Is it clear that the maximum shear stresses will happen between the shaft B and C? Is there any question, ya shabab, about the problem related to the power transmission, the problem related to the to calculate the shear stresses, how to calculate the diameter based on the allowable? Is it clear? Is it clear, ya shabab? Yes, please.
At C, we have it going in. Why we don't have it as a negative?
It doesn't matter here if it is going in or going out. You know why? Because when you will calculate the shear stresses, I don't care about it is negative or positive. I care when it will be the angle of what? Of twist. معايا?
Oh, yes. Yeah.
يعني here I don't care. احنا we said a maximum shear stresses either negative or positive. I don't care. It will be absolute value. Okay. طيب. clear.
clear يا دكتور.
any other question يا شباب؟ any other question يا شباب؟ شباب, is there any other question? Any other question for the all material يا شباب after the midterm? طيب يا شباب, أنا what I will advise you now. I will advise you to read the materials, okay, and try to read it carefully. Try to solve the assignment number 3 and number 4. The quiz will be up to lecture number 30. So it is from, I think, if I am right, from lecture number 20 up to lecture number 30. It is, يعني this quiz is just only 2 quizzes. They are very simple, ولكن you need to know how to apply the formula. If you know how to apply the formula, I think you will see that it is very simple to find, okay, whatever you want to find inside any problem. So what I will advise you, try to read the material, try to go over the assignment, try to just solve it, upload it, be ready for the quiz. Okay, Shabab? This is what I need or I want to advise you, okay, during the break or whatever. I know the break, okay, is very long, لكن you have enough time to take a rest and also to study. Be careful, the summer is very short and immediately you will start, okay, and we will end up with the final exam. I need from you to continue very hard as usual, وإن شاء الله يعني all of you will get excellent grade, okay? But try to study very hard. Right. Any question يا شباب before we will leave?
Doctor,
Yes, please.
for the third and fourth quiz, will
Yes.
the